Okay, today we're going to be looking at getting started on Module 7. Module 7 is looking at what we call working drawings. Now, working drawings are going to be a compilation of everything we need to make like a full assembly. So we're going to learn how to do assembly drawings here, but then we're also going to be learning how, in the event we need to change something, how do we put a revision level on a drawing? Okay, that's something that occurs on a regular basis when you're out in industry. So this is a great place to kind of a look at that. We're also going to be looking at a little bit more formal tolerances and fits applications, kind of building off of what we had done the last module. So here in Module 7, Session 1, our agenda is we are going to be looking at doing Module 7 Practice Problems 1, okay? And then I'm also going to get you started on the assignments 7A and 7B. So there's 2 sets of practice problems and there's 2 assignments here for Module 7. So I'm going to go back to Module 7 here. So you'll notice we have practice problems. So we're going to be focusing on this today during our lecture. And this revolves around revision levels on individual detailed drawings, okay? The next time we get together for practice problems 2, this is going to be putting together a full assembly drawing. And then we have 2 assignments here, 7A and 7B. These 2 assignments are going to be creating the detailed drawings with borders for the individual parts that are going to lead into our final Module 8 project, which is a machinist vise assembly, okay? So next week is really going to be dedicated to kind of bringing everything together, no new information. It's kind of like we're going to do a project that is going to reinforce the items that we've been talking about, but we're getting started on it this week with some individual drawings here, okay? So that's what we kind of have ahead of us. Let's take a peek at our Module 7 practice problems, okay? So when I click on Module 7 practice problems 1, okay, because again, there's a 1 and a 2. What we're going to be doing is we're going to be updating our shaft support detail drawing. Now, we have, I think, done the one of the parts that are in here, but we haven't done them all. But what we have to work with here, there are a couple of PDFs. In the room, I have them copied. So if anybody hasn't grabbed one of each of the PDFs or the papers that are up in the front here, please grab one. But if you are virtual, here is the PDF of each one of these, okay? Now, there is a start file, which is an AutoCAD start file that we are going to be working with. So you don't have to go back and try to dig up any of these drawings, or you don't have to draw them from scratch. I already have them done for you. So what I'm going to encourage you to do right now is to download each one of the DWG drawings, because we're going to be pulling these up in AutoCAD, and these have the full instructions for what we're going to be doing. The PDFs that are up here are truly just reference, okay? So they're just reference. So I just kind of have them in both forms so that if you're virtual and you want to print off the PDFs real quick, you certainly may, but if you're not, that's okay too. You can just take notes. So make sure that you download each of these, the base plate, the bearing, and the collar. Give you a little bit of time to do that. You're going to notice that as you download each one of these and pull them up in AutoCAD, you're going to notice that they are on drawing borders. They're already dimensioned. Everything is here for you. So I'm calling this a start file because this is kind of like if you would get an assignment at work and say, hey, I need you to update this drawing. You got to make these changes. And then what happens is you want to record kind of the history of what has changed, and that's called adding a revision, okay? So we're going to kind of do that here. So I'm kind of giving you the start, okay? And we're going to make some changes, and then you're going to add a revision level to each one of these drawings, and we're going to do this together, okay? So you should have all 3 drawings kind of available to you. So there's going to be this one is the collar, okay? And then you're going to have the bearing, all right? And then the third one is going to be I think it's called let's see, do Do I have the collar open twice? Nope, it's called the base plate, I believe. Yeah, the base plate. Okay, so those three drawings we're going to be working with for these practice problems. Okay. Is there anybody still downloading those or getting them open? Looks like we're pretty ready in the room. Okay. All right. Well, let's kind of look at the instructions that we have on each one of these. All right. I am going to start with the collar. Okay. I'm going to start with the collar. Now, when you open up the collar, you're going to notice, like I said, this is a completed drawing, but I do have some notes up here. Okay. Now, the notes are going to give you what you need to do for the revision. When you hand this in, these notes are coming off, okay? Because it's kind of like you're creating this for somebody, you know, out in industry, if you would, okay? But the notes here are just here for so that you know what to do. So number one, it says, specify an RC3 fit to mate with the bearing, and then add a revision to the drawing documenting this change, okay? So we're gonna do those two things. Now, it says that we want an RC fit that's gonna mate with the bearing. So the other part we want to just look at and pull up is going to be the actual bearing itself. That's here. Now, how these two parts fit together, okay, is that the bottom part of that collar is going to fit in this counter bore on this bearing. Now, underneath my camera here, it's actually in chapter 11 in our AutoCAD book. This is this assembly. We're going to be referencing this when we do the assembly the next time that we're together. But here is that base plate. Here is that bearing. And here is that collar. Okay, so it's chapter 11 in your AutoCAD book if you want to open up to 11-4. Okay, so there's a little recess or a boss in the bottom of this collar that's going to fit into and down onto the top of that bearing, seating into that counter bore. Okay, so that's the fit that we want to determine. So we want to determine, as I go back over here, this 2-inch diameter on the collar needs to fit into the 2-inch diameter of our bearing. Okay, all right. Now, if you happen to be in class, I did give you the PDFs, and this is a place that you can kind of take the notes as we go through. For those who are virtual, you might have to just take the notes and then go from there. So we're going to do this first one with the bearing, and we are going to apply the fit to both the diameter, the inside diameter of that counter bore, and the outside diameter of our collar. Okay. Now, it says on the bearing up here, it says apply that RC3 fit. Okay, RC3 fit. Now, what's an RC3 fit? All right, we haven't really talked about that, but we did talk about tolerancing the last time we were together. So before we get into the RC3 fit, what I want you to do is, based on the diameter of 2 inches here, okay, that we have on our collar, and that it doesn't have a tolerance immediately in back of it, we know that we need to look to our title block for the appropriate tolerance that's going to apply. So if we look here, this is a 2-place decimal, right? And if we look down here, what is the appropriate, or what would be the applicable tolerance that would apply to that 2-inch dimension? Plus or minus, it's actually 0.02, so we would say 20 thousandths. So remember, the thousandths level is that third decimal, so 20, so they say 20 thousandths, or 0.02, plus or minus 0.02. So what I want you to do is I want you to, on our collar, to start off with, I want to list the min and the max based on the title block tolerance, okay? So I would be adding 20 thousandths, right? And I would be subtracting 20 thousandths. So that means my high limit is going to be 2.020, right? And my low limit is going to be 1.80. Is that right? No. 1.998. Yes, 98. Wait, no, what? Yeah. See, this is why I don't do these things in my head. I get all like, I can do this, but I can't. This has been the case for 30 years. I am not good in my head. You know, some people have that gift. Do you ever know that? Yep. Some people can like do things in their head really, really quickly. So I'm not one of them. So 2 minus 0.02. All right, 1.98. And this is going to be 2.02, right? Double check my work. All right. I got my calculator out, so I should be safe. All right. And now we're going to do that very same thing now, the very same thing for the bearing. Okay. So here is that 2-inch diameter, right? This is where that collar is going to fit into. And now we want to put the limits here as well. So the high limit here is going to be the same, right? Because it's the 2-inch dimension, and our title block has the same plus or minus 20 thousandths. So 2.02 and 1.98. Okay. Now, too often when people do designs, they will design just like you see here. And this is what the book did. Okay. And this is why we're doing a revision on it, because they don't even pass it off as this is a problem. Okay. But it's a problem. And you're going to tell me why. If I want this portion of my collar to fit into this portion of that counterbore, what's the problem? What's the problem? What was that? It's called, yeah. And Roman, you're saying it just like you would hear out in the industry. It's size on size, meaning if this is 2 inches and this has the same tolerance, it's going to go up to 2.02 and it's going to go down to 1.98. My worst case scenario here, if you would be my smallest hole, right? The smallest size counterbore, 1.98, and my largest shaft or this end of this collar, which would be 2.02. My collar is 40 thousandths larger on the high side than it is on the low side of my counterbore for my bearing. Do you see that? So that would be a problem. And having that much overlap, I don't even know if I could press it in. That's a lot. That's a lot. Okay. Now, some of them would work. For instance, if I was on the low side here of my collar and I was on the high side of my counterbore, some of them would work, okay? But we don't want some of them to work. We want all of them to work, okay? Because in this case, let's say somebody would make this for us, and they would go through and they would know the target based on the tolerance in the title block, and they would make 6,000 pieces of my bearing, 6,000 pieces of my collar, and all of a sudden, the person who's assembling, it's like, yeah, these aren't all going together. Some of them are, some of them aren't. And you know what the first thing they're going to do? They're going to pull out the drawing. And they're going to find out, did we make our parts to print? Okay, that's where they're going to start. And then they're going to be like, yeah, we made them to print. The counterbores are good. And the outside of the collars are good. And then where are they going to go? The designer, right? The designer. And that these are the things that you have to think ahead, like, oh, that has to go together all the time. And it's easy to forget because sometimes when we're dimensioning, putting a 2-inch dimension on, well, that's what I drew it to. I'm going to dimension to that. Okay. And I want everything to be 2 place decimals. It looks nice, but it's not about looking nice. It's about functioning. Okay. So we have to think of each one of these dimensions that we put on in terms of tolerancing. Okay. Especially when things are fitting together. Okay. So in this case, this part is fitting inside of this part. So what can we do? All right. The nice thing is that there are standard charts, and this is where that RC3 comes in. Okay. This is where the RC3 comes in. So an RC3 fit, we go to the back of our big, thick tech drafting book. Okay. And we're going to do this together. So if you happen to not have this on you, it is okay. All right. It is okay. And you're going to go to Appendix A36. A36. I have the 16th edition. If you have the 15th edition, it's probably going to be a different page. But what we want are the running and sliding fits page. Okay, running and sliding fits. And you're going to see RC 1, 2, 3, and 4 at the top here. Okay. Now, RC fits. RC fits are what we call running clearance fits. That means that at every single level here, no matter what we put together, we'll be able to actually physically have a gap, okay? Whether it's the largest shaft in the smallest hole on the fit that we pick here, okay? It'll always be a little bit of a gap. You probably even feel it a little bit, all right? Those are called running clearance fits. Now, running clearance fits have different grades, okay? RC1 is going to be what we consider the closest or the most accurate RC fit, or the smallest amount of slop or give, okay? And as we move towards RC9 on the second page, now we're going to have much looser fits, okay? Much looser fits. Now at the top of each one of the pages, you're going to notice for each one of these RC fits, these categories, there is a description, okay? So it starts with RC1, close sliding fit, and we go, in between, let's do an RC5. This is going to be a medium running fit. And then you're going to see the one RC8 and 9 are going to be loose running fits, okay? So if you would, closest, and this is going to be the sloppiest, okay, when we get on this side, all right? Now you as the designer would kind of try to line up your application to what that is. Is there one perfect answer? No, no. You're going to pick based on what you believe is the right answer, okay? Or what is the closest description here that makes sense, okay? So for you guys, we're going to use an RC3 fit, all right? I picked it, all right? Now we'll come back to RC3 fit in just a second, but let's turn the page. You're going to notice that we have another class of fit here. This is called clearance locational fits, and they're called LC fits. And they also have class starting with 1, and they're going to go all the way on the next page to an LC11, okay, an LC11. Same thing. When we are in the 1, that's going to be the more accurate or the closer fit, and then we're going to go gradually wider to an 11. Now, when we look at an LC11, this is going to be closer than an RC1, okay? All right, so these start to get into what we call, they say clearance locationals. So we're going to be almost like line-to-line contact, worst case scenario, if you would, size on size, like Roman said. And then there's going to be a little bit of clearance, okay? A little bit of clearance. So it's going to be much closer. Maybe a tap together as opposed to just, pushing them together and they just freely go together, okay? So that's our next level. The next one that we have is going to be a transitional locational fit. Transitional locational fits. And then this is where you start splitting hairs. And interference locational fits. These are going to be where you have a little bit of clearance and a little bit of interference. Okay, dowel pin holes are where these are gonna fit. When we put a dowel pin hole, they're usually in there for locational fits, but they're going to slightly press into one and then just be slightly a nice clearance fit, but close on the part that fits with it. Okay, so locational things are going to be here. And then the last one that we have is going to be the FN fits, okay? FN fits are going to be force and shrink fits. This is when we have material that is going to occupy the same space whenever we're putting it together. This is not a bad thing necessarily. Sometimes we want to press maybe a pin into a plate and we want it to stay there forever. We never want it to fall out. So a force, a press sometimes it's called, or a shrink fit, where we actually heat one item up to expand it. We cool one down to cool it down, and then we put them together. We let them get to room temperature, and then now they're going to stick together forever. Okay. So again, each one of these kind of has a class that goes with it, a category. Usually one is going to be the closest, and then the larger numbers are going to be the less accurate. And then they're all going to have these descriptions on the top so that you can try to nail down where this is going to be. Okay. So again, for our purposes today, I picked an RC fit between those three. Okay. So we're going to go back to our RC3 fit on A36 here. And what we're going to do is we're going to see how this is already figured out for us. All right. So we don't have to try to figure out, okay, what am I going to use for my my values so that they come out okay. All right. So we're going to find our RC3 fit. Then what we're going to do is you're going to notice over on the left-hand side, the very first column, this is the nominal size range, okay, in inches. And this is going to be the nominal size of the hole and shaft that we're working with. And in our case, it's going to be that 2-inch diameter. Oopsie, 2-inch diameter. Okay, so each of these has the base of 2 inches. Okay, so we're going to find then, we're going to go down our column and we're going to find where 2 inches is. And it's right, reach this in a little bit. It is right here. Okay, this is where my 2 inches would fall within that range, 1.97 to 3.15. Okay, and then what we're going to do is we're going to go over to the right. I'm going to grab, open, got my pink here. And we are going to go over and we're going to go to the column where we have the RC3. So looks like the numbers that we're going to work with are right here. Okay, so I just kind of want to highlight it so it's easy to see on the screen. All right, now on the top, just above our chart here, it says the limits are in thousandths of an inch. The limits are in thousandths of an inch. Okay, so now what I'm going to do is I am going to go down here and you are going to notice that we've got a series of numbers. Now, the first column is limits of clearance. Okay, we're not going to worry about that just yet. The two columns that we're going to be most interested in are going to be the hole and the shaft. Okay, the hole and the shaft. And don't worry about the H7 and the F6. All right, those are just kind of older callouts. So we're just gonna look down here and we're gonna go down to these two columns right here. Now, what we're gonna do is it's gonna tell us, okay, on that nominal 2 inches, okay, that we called out, we're gonna add, now the number says 1.2, okay, 1.2, and then we're gonna minus 0, and this is on the hole. So when we look at the hole is on our bearing here. Okay, I'm going to erase these limits right here. Okay, because we're going to have different ones. And we want to know what those are going to be. So I'm going to zoom out just a little bit here. And I'm going to say this is going to be our hole. And this is going to be on the bearing part. Okay, this is going to be on the bearing. Now, my nominal size on my hole is 2 inches. Okay, it's 2 inches. I am going to add 1.2 thousandths of an inch, not 1 inch, 0.2. I have to do thousandths of an inch. So because they didn't want to add all the zeros on this, it would have gotten kind of, crazy with zeros. What we are going to do, since this is thousandths of an inch, we're going to move the decimal place 1, 2, 3 to the left. Basically divide that number by 1,000. Okay, 1,000. So if I just go slightly down here and I say, okay, if I have 1.2, I'm going to move 3 decimals to the left. So 1, 2, 3. Here's where my decimal is going to go. And I'm going to put 1, 2 zeros in front. So the value that I'm adding to my 2 is going to be 0.0012. Does that make sense to everybody? Okay. And then you're going to notice that I'm going to subtract. This is the whole column. I'm going to subtract 0. So I'm going to do minus 0. Oopsie. Zeros. So that means my limits of my hole are going to be 2.0012 and 2.0000. Okay. Yeah. All right. These are the limits of my hole. All right. The limits of my hole. We're going to be adding that as a dimension for limits. And we've done that already. Okay, we had a little bit of practice, I think, in the last module. Okay, so that's the hole. All right, so if we go to our bearing, these are the limits that we're going to put on this hole. So instead of having 2 inches, okay, we're going to have a diameter of 2.0012 to 2.0000. That's going to be the actual dimension that we're going to add in there. Okay. Okay. Now we need to do our shaft. Now, although this isn't a traditional shaft, the collar portion of this is the outside diameter. Okay. So that would be considered what we call an external feature. So that's going to be the shaft column that we're going to determine what these numbers are going to be. So I'm going to take these off of here. Okay. We're not going to use 2 inches. But now what we're going to do is we're going to figure out, okay, what is going to be our shaft number? Okay, so I'm going to do shaft, and this is going to be on our collar. And our nominal is that 2 inches again, okay? And now what we're gonna do is we're gonna go to our shaft. Notice that it says minus 1.2, okay? So that means I'm going to do a minus 0.0012. Remember, I'm going 1, 2, 3 to the left, okay? And then I'm going to have a minus 1.9, or remember, minus 0.0019. 1, 2, 3 to the left, okay? Now you want to get out your calculator, like I need to. And I'm going to subtract both of those values and find what my limits are. Everybody should be doing it. Make sure that you get the same numbers as me. Everybody get those same limits, 1.9988 to 1.9981. Okay, now before we kind of go forward with this, we'll be putting this on our collar in just a bit. It's a good idea to just kind of check, say, okay, as I look here, is my largest shaft on that collar, which is this right here, smaller than my smallest hole? Yes, it is, right? So it always will have a little bit of gap in here, okay? A little bit of gap. So now I'm going to go over to my collar and I'm going to put the two limits that I need here. So this is going to be 1.9988 and 1.9981. Okay. Now, these numbers are going to come in handy, so don't throw this away. These are going to come in handy when we go on AutoCAD and we identify what our limits are going to be. These are going to be on that tolerance tab, and then these are going to be the pluses and minuses that we put in to get the limit dimensions, okay? But then our final limits are going to be the values we see here. So that is applying the RC 3 fit to both of those, okay? So if we look back at our AutoCAD drawing on our collar, that is the only change that we need to make. Just specify an RC3 fit, which we just did for that 2-inch diameter. And then we need to add a revision level. I'll show you how to do that once we get the other items done here. Okay, so that's the first one. Then we're going to go over to that bearing. Okay. And you're going to notice down here, the notes are down here, the updates that we're making. Specify number 1 an RC3 fit to mate with the collar. We just did that one, right? That one's already done. The second one says we want to specify a depth for that 2-inch counterbore to always seat the face of the collar. All right, always seat the face of the collar. So. If we go back to our collar, you're going to notice that we have a dimension of 1/4 of an inch here, okay? If we go to our bearing, we have 1/4 of an inch here. So we see the problem, right? Just kind of like the last one. If we seat this down and this is on the low side, right? This could then mean that it is seating on the bottom of that counterbore instead of on this surface. And we want that collar to always be on the surface, okay? Now, in this case, this isn't as critical as two things fitting together like we saw earlier, okay? In this case, we could figure this out without having to necessarily do the fit chart, okay? And I would suggest doing that because it's not a 4-place, 5-place decimal dealio. This is going to be, we just want to make sure that our numbers are good. So if we go back over here, what we're going to do is we're going to look at our collar. I'm going to leave the 1/4 inch dimension right here. I'm going to let this one be exactly what it is. So what we need to do on that collar is we need to figure out, okay, what is the high and the low value here? So again, this is a 2-place decimal. We're going to default to our title block, plus or minus 20 thousandths. So our limits here, I'm going to put them on the other side, are going to be 2.7, right? And 2.3. I'm sorry, 0.23 and 0.27. Okay. Now, worst case scenario, if I want this to always be seated, right? I always want that to be seated. Worst case scenario is I make this to 0.27, right? I make that to 0.27. So when I go to my bearing, okay, I need to make sure that my minimum value is larger or deeper than that 0.27, right? Okay. I don't think I want line-to-line contact because I don't want the bottom to seat. So what I'm going to do is I'm going to start my low value at 0.2. What do you think? 0.2 larger or smaller than 0.27? Larger. I need it larger. So what do I want to start at? And I'll actually ask, I'm going to ask my virtuals. You guys tell me, what do you think I should put in? I'm going to watch the chat box here. What should I put in as my minimum? Okay, so I'm going to start at the bottom here. I'm going to put a number on top, but what am I going to start at the bottom with? 0.2. It'd be a long night. We're going to let miss the Zooms. Why couldn't it be 0.27? Well, as I said earlier, I want to ensure that it's always going to fall here, right? If for some reason, and what can happen if I go back to my collar, okay? If I go back to my collar, let's say that surface is not completely flat, okay? Let's say it's not completely flat and it's sitting a little bit at an angle. I could have a problem where it doesn't sit in there, okay? That's going to be a GD&T problem. So you get to look forward to GD&T when we do that. But it could not, there's a chance this couldn't be, this could be uneven or not perfectly flat. So if I do 0.27, I still might have a problem actually seating on this, okay? So that's why you don't want to use 0.27 when you want to ensure that it's going to sit there. Does that make sense, Dominic? Does that help answer that? So minimally, I want to be a little larger than 0.27. So Aaron is like, how about 0.29? Okay, I'm okay with 0.29. Are there any other numbers we could do? 0.28. We could, absolutely. Okay, so this becomes not one single perfect answer. You could go 0.3 maybe if you wanted to, all right? If there isn't a reason why that counterbore can't even be deeper, why risk it, right? Why have it on size, okay? So any one of these numbers, 0.2, 0.28, 0.29, 0.3 would all be acceptable values, okay? So what we're going to do is we're going to go back to here, okay? And I am simply going to pick the first one that came up, and Aaron got it in there first. I'm going to do 0.29. As long as your number is greater than 0.27 on the minimum, that's all I want to see. Does that make sense? So you have some autonomy here of what you want to do. Then, since we have plus or minus 20,000, so for a 2-place decimal, it's a total of 40 thousandths, right? Now we could put our high number at whatever we want, but this is not a critical dimension. Would you agree? It's just a depth to make sure that we don't land on that bottom portion. So I'm simply going to add 40 thousandths. Okay, so now I got a 0.29 plus 0.04. So that is going to be 0.33. And that way, our tolerance here is 40 thousandths, which is consistent with a 2-place decimal. Could you do 30,000? Sure. Could you do 20 thousandths? Sure. You're the designer. Okay, so you can make it as wide or as little as you want, keeping in mind that you want to keep this as manufacturable. You want to keep your target as big as possible so that it doesn't take a long time to achieve. Does that make sense? I don't want anybody taking a cleanup cut on that counterbore depth. I want it to just be there within that limit and I'm done, so that I ensure that this is going to seat our collar on that particular surface. Does that make sense? Okay. All right. So that's going to be that part. Okay. So we've got those two updated. So let's go back to our CAD on our collar, see what else we've got to do. So we adjusted that 2-inch depth. Then we want to specify a standard through hole and counterbore diameter for a 3/8 inch diameter fastener specified in the subassembly. Okay, so if we go back to that AutoCAD, and you don't have to open it up because I've got it here. I've got it here. My book just closed, but I will get it right back up here. Okay. Beginning of that. Okay. So let me go back underneath here. So here is that assembly again. And what they're referring to here is you're going to notice the two holes that are in the base of our bearing, they are going to accommodate two fasteners, okay? Two fasteners. And those fasteners have to go through the through holes, and they're going to be seated on the counter bores. I already know that the counter bore diameter is totally fine, so we don't have to worry about that diameter, but the through hole is the problem. The size of our body or of our fastener is a 3/8 inch, so 0.375. Okay. So if we look at the through holes on that bearing, and again, this is the design in the book, which kind of drives me crazy. You're going to notice that the diameter of the hole is a diameter of 0.38 or rounded 0.375. So the size of the through hole is the same size as our fastener. So same issue again. We're going to have problems. Some of them are going to fit, some of them aren't going to. Now, if you remember from last week, when we did that fastener charts, you remember there was a column for standard clearance holes, right? Do you remember how much bigger we wanted to make that standard clearance hole from the nominal size of our fastener? So I'm going to go underneath here really quickly. So our fastener is right down here. I know it's kind of hard to see. This is 3/8 of an inch, 0.375. We want this body, remember this body, the very largest that it's going to ever get is going to be its nominal size. That's metric, that's English, that's always the case. So if we know it's a 3/8 inch diameter, that's the largest it can get. So how much bigger am I going to make the clearance hole for this to go through in order for that to work? You guys, oh, Thomas has it, a 32nd of an inch, 0.03125, right? Remember that was a 32nd of an inch larger. And the reason we do that is because that coincides with standard drills, right? We can pull a drill off the shelf and we can use it to create this clearance hole. So what we need to do then is we are going to figure out what is the size of the clearance hole that needs to go through there. It's not 0.38. What is it going to be? If you don't know what a 32nd is plus 3/8 of an inch, you should be putting it into a calculator to find out what that is. Tell me what it is. What is my diameter right here? It's not going to be 3/8 of an inch. It's going to be a diameter of what? 4.85. So Deborah has point what? 0.34. 875. Now, be careful. I'm wondering if you maybe did the wrong one. So 0.375, we want to take 0.375, a diameter, that's the diameter of our fastener, and we want to add 0.03125. 0.40625. Is that, anybody else get that? That sounds correct. So maybe you just added it to the wrong number. That's okay. Okay, so a 32nd larger than the fastener. Okay, now I'm going to kind of get rid of this. Well, I'll do this work over here. So I'm going to say diameter of 3.375 plus 0.03125, 0.40625. That's going to be the diameter of our through hole. And the through hole is always listed first when we show a counter bore. Okay, so it's going to be that value right there. Now, we are not going to show it to 4 decimal places or 5 decimal places. We are going to round it just like we did here. That's totally acceptable. Okay. So in this case, we're going to keep it to a 2-place decimal. It's not super critical. We're giving it a 32nd of an inch gap already. Okay. So we can round this to, I'm going to actually truncate it here. Okay. We're going to round it to 0.41. That's it. Okay. So it's going to be a diameter of 0.41. Now, you're also going to draw it to that number. You're not going to just change a note because right now this is a dimension. This is not a note. Okay, so it's an actual dimension. So this 0.38 is tied to that through hole. So on this drawing, we need to update the diameter of that circle. Okay, so let's go ahead and do that. And we're not going to do it to 0.41. I'm going to tell you what you're going to do it to. Okay. So here's our start file, right? So we want to go to that AutoCAD file. We want to go to that AutoCAD file and we're going to click on that hole and we're going to delete it. Okay. We're going to delete it. And then we're going to change this to object line layer. And we are going to put in a center diameter hole at that location. And it is going to be 0.40625. You are going to hold it to all 5 decimal places and we're going to let our dimension then do the rounding for us. Do not draw this to 0.41, okay? You are going to be handing in the files for this. I'm checking that. I'm going in and I'm checking it, okay? So then you're going to hit enter, all right? And now notice that our dimension didn't update. It's not going to. So I'm going to hit it. I'm going to select it. I'm going to delete it. I'm going to go back to my dimension layer. And we are going to go to, now if you have this bar up here, it is going to be on the diameter dimension. Okay. We're going to click on that diameter dimension and we're going to click the inside hole. Okay. And now you're going to notice that, oh, look at that. It updated. Okay. If you do it as a note, that's fudging a dimension. Okay. Always tie your dimensions to the actual physical size of your feature, okay? Now, we've got to add the information about the rest of the items here. So we're going to double click on this. It's going to go into that text editing mode. We have 2 holes here. So you're going to be to and by. Oops, I got to make sure that that is a capital X and a space, okay? I've been seeing a lot of people forgetting the spaces there. You to and by are together, but then it's a space before the diameter. Okay. Now that is going to be our through hole. So now I'm going to do an arrow to the right to get to the end there. And then I'm going to hit enter and it's going to go to my next line. This is where I'm going to add in the symbol for the counter bore. Okay. So if we look underneath here, I've got to add that counter bore symbol and then the diameter and the depth of that counter bore. So I'm going to go back to AutoCAD and right up here, because it's in that text editing mode, there is a place where it has symbols. Okay. So I'm going to arrow down and unfortunately they don't have counter bore in here. I don't know why they choose the ones they do, but they don't. So we need to go to other. And now it's going to come up with that chart. Make sure that you are on the GDT font, okay? If you have to arrow down, go to GDT, all right? And then we're going to notice, this is what's, and depending on, maybe it's because mine is on a laptop, it might not be as big, but on the bottom line here, if we click, that's a horizontal line. That's not the one I want. I want the one next to it. So I want to make sure that it is the counter bore symbol. Okay. Now, once I have that selected, so it's in the GD&T, it's the bottom row here, and it's the counter bore symbol. It's just to the left of the countersink symbol, which is like the V looking one. I'm going to hit select, and then it's going to put it down at the bottom here. Now, because of the fact that I also have in that same line, if I go back underneath here, I've also got the depth symbol. I'm going to add the depth symbol in right away because I'm here at the same time. So I'm going to go back over here. Went out when I went there. That's okay. I'm going to go back to my symbol, other, and then I'm going to grab this. Okay, so I'm going to select that one. And then I'm going to put a space in the middle. And then to the right 2 spots, there is the depth. and I'm going to select that one as well. So I'm going to put them both in. You can do them separately if you want to. It's just like I kind of figured, just to being efficient, I can grab a couple of them here, put a space in between so you can add the items that we need to. And then I think we can say copy. Yeah, copy. And then we can close this, and then we can do a right click and do paste. Okay. And now they've gone in there. I've added a line. That's okay. I'm simply going to go back up here, and I'm going to add a space after my counter bore. And then we need to put the diameter in. The diameter can be one of two ways. Now, the diameter symbol is in the symbols up here, and you're going to notice it's right here. Or you can do %C. That is the diameter symbol, but it's right here. We're going to hit diameter, and we're going to put in 0.63 because that's our number, space, and then the depth symbol, and then we're going to go to the right, and it's going to be 0.13. Okay, all one. So counter bore diameter 0.63, depth, space, depth 0.13. All right, now I'm going to just click off of this. Don't hit enter because it'll just add another line. Just click off of it. And now what you're going to notice is my top line, the font size is larger than my second line. Remember when this happened the last time? I don't know why AutoCAD does this, but all we're going to do is we're going to reselect that, double click it. And you maybe could do it when we're in that other mode, but you're going to just select the bottom line. Do not select the top line. And up here in, right underneath annotate, notice that there's those numbers. It goes to 0.0938. Why it does that, I have no idea. But if we go down to 0.25 or 0.125, you're going to notice that now it's going to be the same size as that top line. Okay. And then you're going to hit enter. One very last thing, and this is very ticky-tack. Kelly will never take off for this on your drawings, but if you want things to be right on, we're gonna reselect this, and we want all of this to be justified to the left. Notice that we have it centered here. So if we go up, is that here? Don't think I want it in text editor mode. Hold on. Oh, here's the justification. Right underneath the A, it says justification. We arrow down, and we want this to be top left. There we go. And then now what you're going to notice is that everything shifts over to the left. If you were on the other side with a leader, then it would go to the other side. Okay. I will never mark off if you leave it centered. It's okay. It's okay. But it's one of those little things that I will always update on my drawings. And I'm not saying it's my way is the only way, but just so you know, if you wanted to correct that and show that justified one way or the other, that's how you would do it. All right, so now that is all set. So we did number 1, we did number 2, we did number 3, okay? And now we're ready to add a revision level then, okay? So before I add my revision level on any one of these drawings, on all 3 of these drawings, wherever the notes are for the updates, you're going to select and you're going to delete. Okay. Because remember, you're releasing them for production. Okay. Now, the next thing that I need to do is I need to identify where I made the changes. Now, the revision level that we're going to start is going to be with the letter A. Okay. So that's how you start revision levels on a drawing. If it's the first revision on a drawing, it's going to be revision A. So we're going to be on our dimension layer line. And then we are simply going to go to the 2 places. Oh, no, we have to do the 2 first, but I'm going to do this one first because we already have this one done. I don't want to forget about it. And we're just going to go to the text. So you're going to notice that on our home ribbon, you can either do it in annotate or you can do it at the home ribbon. And if we arrow down, we're going to say single line text. Okay. And we want this to be 1:1. I believe that's the scale of the drawing. Yes, it is. So we're going to say, okay. And we're simply going to specify the start point. And we're going to hit enter. Why isn't it? Hold on. Specify single line. Let's do multi-line instead. Sorry. Just make a left click and then a right click just for a box. I think that's the easier way to do it. And then we're going to put in letter A. capital letter A. Now, for some reason, it is on 0.2 again. So if you go up here, it's in the text editing mode. We want to get it down to 0.125. You probably have to backspace, go down to 0.125, makes it a little smaller because we want all the text to be the same size. And then once we have that, we just left click outside of it and we have a letter A. You guys see that? So I'll do that one more time. I'm going to do multi-line text, left click, upper left, left click, lower right, change your annotative to 0.125, and then do the letter A. Now, if this was the second revision, and then just click outside of the box and then it ends it. If this was the second revision, it will be B, third revision, C, and so on, okay? Now what we're going to do is we're just going to move it, okay, so that it's going to be by that dimension. So I'm going to select, I'm going to do move, select it, and then I'm just going to go from, turn off my ortho, just going to kind of put it right by the front of that dimension, okay? Then the last thing I'm going to do for a revision level, so we understand it's a revision level and not just a floating A, we're going to put a circle around it. So we're going to put a circle, center radius, go right about in the middle of that A, and then you're just going to create a circle around it. And that's it for the revision level, as far as identifying it on the drawing. Okay, so it's just an A with a circle around it. Okay, so that's revision level A. Let's do a quick file save on our drawing, just so that we don't lose it. All right, now let's update that 2-inch dimension, okay? So this 2-inch dimension, I'm just gonna delete it out of here because I'm not gonna do the 2-inch. Now, we know that that dimension, if I go back underneath, this needs to be to 4 places, right? To 4 places. So right now, see, on my drawing, I do not have a 4-place decimal. I don't have a 4-place decimal. I have 2 and 3, right? I have 2 and 3. So we need to create one, all right? So what I'm going to do is I'm going to select my 3-place decimal, and just to the right, I'm going to go to my dimension manager. Now, if you don't have this toolbar out, that's okay. You can go to annotate. You can select the 3-place decimal up on top here, and then in the dimensions on the right-hand side, the little down arrow will get you this dimension style manager, okay? Now we have 3-place selected. We're going to say modify, okay? Modify. And all we're going to do is we are going to go to, oh no, I'm so sorry. Don't modify. We want to make new. I'm so sorry. We want to leave the 3 there, select the 3. We want to make new. That's what I was expecting. So now I want to say 4_place. And I'm going to say, okay. That's going to be my new style based on the 3-place. I want it to be a 4-place. So click new while 3-place is done and then call it 4-place. So now you're going to notice our new dimension style is 4-place. And what I want to do is I want to go to my primary units here first. My primary units need to be underneath decimal. We want to go to where the zeros are and we want to go to 4-place decimal. Okay. So on the primary units tab, 4-place decimal. Then we're going to go over to tolerances. If I would leave it at 4-place right now, it would be just one number for my tolerance. I want those limit dimensions in there. I want the high and the low value. So I'm going to go to the tolerances tab. And the method says none. I need to arrow down and go to limits. Now, the precision is at 4. Perfect. So I don't need to mess with that. But now I've got an upper limit and I've got a lower limit. Okay. So the upper limit, this is where I'm going to put those tolerances in from the chart. So since this is the whole side, right? If I go back underneath here, my whole was plus 0.0012 and minus 0. So because I drew it at 2 inches and 2 inches is my nominal value, I can use these numbers right here. So 0.0012 is going to be my upper value. And 0.000 is going to be the lower value, okay? And everything else should be the same, okay? So I'm going to, oh, I stand corrected. We need to suppress our zeros here. How come that's, oh, that's for alternate. No, we already suppressed the zeros, I believe. Let's just double check. Let's go to primary units. Leading 0 is suppressed. Good. On English drawings, remember, we don't have a leading zero. Okay, you might think, well, is that a big deal? Kind of is. Okay, it is. It's the standard. It's the standard. So so please just pay attention to that. So I'm going to hit OK. I'm going to set as current, and I'm going to close. Now that is my current. So notice up here, if you have that toolbar out, it says for place. Okay, and also if you're on the annotations tab up here, it says for place because I set that as current. So now what we're going to do is we're going to redimension that counter bore. So I'm going to take a linear dimension, which is right here, the very first dimension on my toolbar, or if we go to the home screen, the home tab, it's the very top one here, linear dimension, okay? So I have a linear dimension, and so it says specify the first extension line. I want to go to that counter bore, the top, the bottom of the counter bore, and then I'm just going to pull this out, 4 place decimals, top and bottom, okay? Anything missing? The diameter symbol, right? I'm missing my diameter symbol. So I'm going to double click on this and I'm going to go out. Notice that it starts in that text editing mode again, right? So I can add the symbol over on the right-hand side here for the diameter. It's the third one down. I'm going to click on it and notice that it places it right in the middle for me. Okay. And then I can click off. And now you're going to notice that we have the diameter symbol in front. Okay. So make sure you do that because this is a cylindrical feature. All right. And now I need to add my A. Now I already drew an A. What can I do? I can use this one, right? I could copy it. So I'm going to go up to the top here and you're going to notice that right below move, there's copy. So I'm going to click on copy. I'm going to select not only the circle, but the letter. I'm going to hit enter. And now my base position is going to be at the center of that A, and then I've kind of got it. And then I'm going to put it right about there to identify that that is also something I revised during this A revision level. So I just copied my original A there. Does that make sense to everybody? Okay. So now in 2 places, we have the A with the circle, which is our revision. And now I have to identify, all right, what did I revise? And my revision block is up here. Now, you're going to notice that at the moment, I would add to the bottom here, but there's not much room. So I am going to move my views down. This is the beauty of CAD. I can move things away so that they're going to fit. So I'm going to go to move. I'm going to grab, left click, and grab just, all of my views here. I'm going to hit enter. And I am going to left click, and I'm just going to kind of move this over to the right and a little bit lower, making sure not to cross over into my title block. If I need to, you can always move your dimensions up a little bit, and then you can move again if you need to. Okay, I think I have enough room up there for what I need to do. Okay, not a bad idea to do a quick file save so that we don't lose what we have. All right, and now what I want to do is I want to fill in this block. Now, unfortunately, there's not like a macro that we can do it automatically. So we've got to kind of build it so that we identify the items that are here. So all we're going to do is we're going to be on our dimension layer, okay? And we're going to start by putting in a couple lines. So I'm going to start with a line on the corner here with the zone, and I'm just going to do a vertical line. So having your ortho on is a good idea here. And then I'm going to go between each one of these about the same level down. Just do a line going down for each one. And line, and so on. Okay, so just the vertical lines for right now. Now I'm going to add in my text. Okay, I'm going to add in my text. So I'm going to go to text, multi-line, and I'm first going to start. I'm not going to worry about the zone. This is an A size drawing. If I had a big roll size drawing or a D or an E size, even a C size drawing, you'll notice that, and it doesn't do it on an A size or I'm sorry, it's a B size drawing. They'll have zones on there where it'll be like an A column and then it'll be like a number row. And then you can put the zone in there. We're not going to put the zone. This is a relatively small drawing. All I'm going to do is I'm going to add a left click, a right click, so I can put my letter A in. Before I do, I'm going to change to the 0.125. So it's the same size text. And we're going to put in letter A. And that's it. And then I'm going to click outside of it. And then I'm simply going to move it so it's at about the center. And I don't want it too high and I don't want it too low. Okay. And then the description is we're going to do that very same thing. So we're going to do the text, multi-line, start on the upper left, and then make it about, maybe wide and maybe, so we could fit at least 2 lines in. We're going to change the size of the text to 0.125 at the top there. And then we're just going to put in was, all caps, 2.00 diameter, colon, or semicolon actually, and was 0.25. That's it. Okay, that's all you have to do. Because we had 2 dimensions. One was 0.25, and we changed it to the limits. And then we had the one that we just did, the 2-inch diameter, and now we changed it to limits. Okay, and it's that simple. You don't have to go into, a really long description. You just want to kind of keep it straightforward and easy. Okay, and then once we have that, we can click off of that. And then now all we're going to do is we're going to put a bottom on here. So I'm going to still be on my dimension layer. I'm going to grab my line and I'm going to try to, I don't know, I guess midpoint for what I have, maybe just go a little bit below. So it's not crowded. And then we just go perpendicular here. So it's just so that there's a nice table. And then I'm going to trim off the parts that I don't need at the bottom here. Okay. And then I'm probably going to move this just so that it's about in line with that A there. Okay. The last thing I'm going to do is I'm going to add the date. So I'm going to grab my text again, multi-line. Okay. Change it to 0.125. Again, not sure why it decides it wants to do what it's doing, but 9/29, 2025, oopsie, 25. Click outside and then just simply move it down a little bit so that it's, I'm gonna turn off my ortho so that I can kind of get it in the middle-ish there. There we go. So any questions or does anybody need to see anything again? I'm going to do a quick file save. And this is our bearing. Ava.
You change the quarter inch, and I will do that, and since it's.
Oh, we didn't do the quarter. We did do the 1/4 inch and we didn't do that yet. Oh gosh, I forgot. See, that's why. Thank you. Yes, we have to do the 1/4 inch here. Yep. Yeah, so let's do the 1/4 inch. Thank you, Ava. I forgot that we didn't do this one yet. So let's make sure. So we've got one more here for our revision A. Sorry, I thought we were done. I forgot about that one. We'll make sure that we do it on the next one. So so we're going to delete our 0.25 here. Okay. And now that is going to remain a 2-place decimal, right? And if I remember correctly, I'll go back underneath here. We decided that we were going to be 0.33. At least I did. I decided mine was going to be 0.33 to 0.29. Okay. So now what we want to do is we want to update that feature because we had it drawn at 0.25. It's now going to be deeper, right? So what I'm going to do is I'm going to find the middle of this dimension. Okay. So the middle of that dimension, I believe, is going to be 0.31. Does that make sense? Right? 0.31. So I am going to go to AutoCAD and I'm going to move my line so that it's offset to 0.31. Okay. So I'm going to go to offset. And there's multiple ways that you could do this, to do this construction. And I'm going to go 0.31 and I'm going to take my left side and go to the right. Okay. And now you can see that I have to trim and I have to get rid of some things. So I'm going to get rid of this dimension, delete. I am going to now trim and extend the items that I have here so I can make my counter bore. So I am going to, underneath my trim where my scissors is, I need to extend, okay, this line to there, okay? And I'm going to do that same thing down here so that that one goes there. Then I'm going to hit escape. And then I'm going to go to trim. So I'm going to go back underneath, get trim back up to the top there next to the eraser. I'm going to trim back this, this and that, okay? Now, I have one other problem. I'm going to hit escape here. You're going to notice that my hatching is still over the top, right? Okay. So I'm going to click on my hatching and I'm going to delete it. Okay. Because I have to, it has new boundaries than what it was before. So I'm going to go back up to my layers. I'm going to switch this to X hatch. And then I'm going to go to my hatch function, which is in the draw menu, the bottom right. I'm going to click on that. I'm going to make sure ANSI 131 is selected. And then I'm going to go into, before I click, I'm just going to hover over the areas that I need. So the first area is here. That looks good. I'm going to left click. Then I'm going to go up here. I'm going to left click, and left click. Okay. And once you have those three back in so that they are where they're supposed to be, we can just hit the green check mark to close and accept that. All right. Now, adding the dimension, that's where you were going, right, Ava? So now here, I have a choice. I really do. I'm going to go back to my dimension layer. And if you remember, if you did the same thing I did, let me go back underneath here. My difference here is 40 thousandths. I just drew it at 0.31, which is plus or minus 20 thousandths. Can I just put in 0.31 and get the same result? Yeah, I can, because my two-place decimal is plus or minus 20 thousandths, right? So at 0.31 plus 0.02 is 0.33. Minus 0.02 is 0.29. So I'm going to leave it as a two-place decimal, but now it's going to have a nominal value of 0.31. Does that make sense? Okay. So I'm going to go back over to AutoCAD. Now, if you put the limits in, that's fine. That's totally fine. But you can kind of see here, if you kind of strategically set it up, then you don't have to. So I'm going to leave mine off. I'm going to make sure I have to go off of 4-place decimal. I'm going to go down to 2-place decimal. I'm going to click on my linear dimension, and I'm just going to go from one edge to the other. And there it is. Okay. 0.31. And again, same result because it's a plus or minus 20 thousandths. So I'm still going to have my highest value 0.33 and my lowest value 0.29, which is still going to obtain that, that collar always seating on the bottom. Okay. All right. Now I need to actually add, put an A by that one. So I'm going to do another copy. A and the circle, enter. I'm going to go towards the center of that A, and then I'm going to just put right about there so that we have that identified. So now we have our revisions done. Oh, you know what? I didn't add in this one, did I? Guys, it's Monday. I'm going to go back up here, double click on this, and then I'm going to do a colon was 0.38 diameter. That was that counter, that was that through hole. Okay. So we've got a was 2 inches diameter. That's this one. We've got a was 0.38 diameter for this one, and a was 0.25 for the 0.31. Okay. So 3 revisions identified up here, limit dimensions, and I'm going to do one last save. That's the bearing. That one's all done. You will be uploading the file because I want to check that you updated the diameters and such. Okay. All right. So what we're going to do is we're going to go back to our collar then. So I'm going to go over to my collar, and we are going to update the collar. And in this case, we're going to be leaving the 0.25 because we said that one's going to remain the same. And we adjusted then the counterbore depth. So we don't have to worry about that. But what we do need to do is we need to add in the limits of this hole, right? So, or I'm sorry, the outside diameter of that collar. So the 2-inch diameter. So I'm going to delete that out. I'm going to delete my note on top. And then what we're going to do is we're going to look, okay, I'm in a new drawing. I have to see, do I have that 4-place decimal that doesn't cross over session wise? It sticks to the part. So what we need to do is we need to create that 4-place decimal again. I'm going to start with that 3-place decimal. We're going to go to the dimension manager, style manager, create new, and I'm going to say 4-place. I'm going to continue 4-place dependent on that 3-place. I'm going to continue. And now we're going to go to the primary units tab and we're going to make it 4 places. Then we're going to go to the tolerance tab and method, we're going to go down to limits. Okay, so primary units is 4-place right here, and tolerances is limits. Okay, now my upper limit, I'm going to go back to my color and the numbers that I got from my chart. I'm going to go underneath here. And on my hole, wait, no, not my hole. On my shaft, my collar, my tolerances were a minus 0.0012 and a minus 0.0019. Now, the way AutoCAD does this, we drew it at 2 inches. We're leaving it at 2 inches. We're not going to change that dimension. So what we're going to do is we are going to go back to AutoCAD here. Now, on the upper limit, it always adds. If we needed to subtract, like we see here, we're going to put a negative 0.012 or 0012 as our value. Put the negative in front. And then on the bottom one here, do not put a negative because it automatically subtracts on the lower level. This is going to be 0.0019. If you put a negative, it's going to add it on the bottom. Does that make sense to everybody? Okay, so we don't want to do that. So then now everything else should be okay. Set as current and close. Okay. Now what we're going to do is we're going to do a linear dimension to the outside of that. And then we're going to look at our values. Is that what we're expecting? 1.9988 and 1.9981. Yes, Ava. In the tolerances. So if I go back to modify and I go to tolerances, I'm going to be a negative 0.012 on top and keep it positive 0.0019 on the bottom. Okay. Any other questions here? Yeah, the negative has to be in the top because that upper limit AutoCAD will add. Okay, so we need that to be negative. And then the bottom limit will always be subtracted. So we don't want to repeat the negative, otherwise it'll add it in. So I'm going to hit close. And now the last thing I need to, well, 2 things. I need to double click on this. And in the front, I need to add the symbol for the diameter. Okay, you have to do that. That is important. Don't forget that. All right, because that tells me that that's a circular feature. Okay. And then I can click off of it. And I've got the diameter. And then the last thing I need to do is add my revision level. Okay. So I'm going to go up to my text, multi line, left click, and then now make sure that you go from 0.2 to 0.125, or if it's something else to 0.125. Put your A cap, and it's a capital A. All text is always capital on a drawing, and then just left click anywhere on the drawing, on the, draft width area, and it'll move. And then I'm going to add the circle center radius. I'm going to go into about the center of that A and just create a circle around it, right? And then now I'm simply going to move the A and the circle, and I'm going to start in the middle of it and just kind of move it down towards that dimension. Okay. There we go. I'm going to do a file save. So we now have that dimension updated and we have our revision level next to it. And then the last thing we need to do is to identify this revision up here. So again, we're going to do the lines, just going down. Oopsie. My ortho back on. There we go. Okay. And then I'm just going to do my text, multi-line text. Oopsie, I do that. Multi-line. Okay. Make sure that you change it back to 0.125 before you get started. Okay. And then multi-line here. Again, 0.125. And then was 2.00 diameter. Was only that one change on this drawing. And then now I'm going to put a horizontal line at the bottom all the way to the end, and then trim off the bottom portions. Oh, I can't forget my date. So I'm going to move here, turn my ortho back off. Okay. And then I'm going to do one last multi-line text for my date and change to 0.125. And this is going to be 099/29/2025. There we go. And then I'm just going to move it up slightly so that it's in the middle here. There we go. And now that should do it. Save. There we go. Any questions? So this one just has, the collar just has the one revision, and the bearing had 3. Okay. Yes.
On the very.
The what?
On the bearing.
On the bearing. Oh, on the bearing. Okay. Okay, but I'm asking, is there anything on the collar that anybody has? I'll go back to the description after we're done here. Any other questions? Okay. Virtually, you guys good on the collar? All right, and I'll go back one more time to the bearing. Okay. So here we had 3. We had the diameter of 0.41. We increased, so that would be a standard clearance hole size for a 3/8 inch fastener. We put the limits on the counter bore, and then we increased the depth. So then up here, our description was, there was 3 items: was 2-inch diameter, semicolon, was 0.25, and then semicolon, was 0.38 diameter. Okay. All right. So make sure you save so that you have everything recorded. So I'm going to do a file, save. And then that's going to be the first part. We're not done yet because we have one more part that we have to complete in these 3. And then we'll be all set for our practice problems. But before we do that last one, let's take a little bit of a break and move around a little bit, and then we'll be back to finish up the base plate when we get back.